2-4 is going to start our formal writing of proofs, and we're going to relate it back to algebra and solving equations, something that you are familiar with and very good at, but we're going to be adding on the reasoning part, which is proving why something is the way it is. So we want to solve 2 times the quantity of x plus 3, subtract 5 is equal to 5x plus 4. We are going to set up our proofs this way. So on the right-hand side is going to be, let's start with the left-hand side. On the left-hand side is going to be our statements, so that's going to be essentially our work. And then on the right-hand side is going to be the reasoning. That's the proof part, is explaining why something is the way it is. Notice that we are going to organize this as a t-table. Okay, so this is the t-table aspect of it. And numerically, just to help organize our work. So number 1 is what they're asking us to prove, all right? And then that is always going to be labeled as our given, all right? So as we come across different problems in this section, equations that we're going to solve, that will always be number 1. All right, and then we're going to work from there, and we're going to keep numbering so that we can keep organizing our work. So number 2, if I were to go about solving this, I would distribute the 2 through to my parentheses. So that's going to become 2x plus 6. And then I'm going to recopy the rest of my work. All right, and then what did I do? To go from step 1 to step 2, I use the distributive property. So I'm going to list that as my reasoning. So I'm just writing in words the steps that I am taking. That's the only difference from solving this from algebra. All right, number 3. I'm going to choose to combine my like terms. So on the left-hand side, I have 2 constants of 6 and minus 5. So I'm going to combine that together to make positive 1. All right, and what did I do? My reasoning, I combined like terms. Step 4, I'm going to bring my x's together. So I'm going to subtract 2x from both sides. So I'm going to show that work. 2x plus 1 is equal to 5x plus 4, and I'm going to show the subtraction of 2x from both sides. This is the subtraction property of equality. So let me write that down first. Subtraction property of equality. Remember, when we solve equations, we want to balance them. If we subtract on one side, we have to subtract on the other side. That's what the equality part is referring to, is subtracting from both sides of the equation. So I'm left with 1 equals 3x plus 4. And what did I do for that? What's my reasoning? That's just I simplified. And yes, you have to show these steps. All right, from here, I am going to subtract my 4 from both sides. So I'm going to rewrite this equation, but now I'm going to show subtract 4, subtract 4. Once again, subtraction property of equality. Step 7, I'm going to do the subtracting portion. So I have negative 3 is equal to 3x, and I simplified. All right, and then finally to isolate x, I'm going to divide by 3. That's my division property of equality. And x is finally by itself, so -1 is equal to x, which is simplify. Starting with algebraic proof helps us to set up how proofs should look with our t-table, our organization of numbering. Notice that each statement is directly related to the reasoning that is numbered the same exact number. This will help me with reading your work and organizing your work and your thought process as well. If you don't have a piece of paper out, you'll want to get one out now to write down. These are all properties that are going to be used in the reasoning section, so the right-hand side of your proofs. These first 5 are going to directly relate to our algebraic proofs. So the addition property of equality is just when you add a value to both sides, or it can be a term. All right, remember the equality part is what you do to one side, you do to the other. Subtraction is when you subtract a value or a term from both sides. Multiplication property of equality is when you multiply a value on both sides. Division property is where you divide the same value on both sides. All right, so those ones are pretty straightforward. And yes, you have to write property of equality with whatever operation you're working with. Substitution is when you replace it. So if I know x is equal to 3 and I have the formula 2x plus y is equal to 10, when I take out the x and I put in the value of 3, that's a representation of the substitution property. Distributive property also has to do, that should be yellow. This is more of an algebraic property, but the distributive property is when you multiply that outside value through to everything inside the parentheses. The next 3 terms are going to be used a lot, or the next 3 properties are going to be used a lot when we get into geometric proofs. So the reflexive property just is the identity property that something is equal to itself. So when it says A is equal to A, that's like when we check for all real numbers. That's at the end of an equation where 5 is equal to 5. A number is equal to itself. This can also be used with segment lengths. So if we're measuring 2 different segments and their units are the same, so let's say we're measuring 2 different segments and they're 7 inches. So 7 is equal to 7, or segment AB is equal to segment AB. And then the same with angles. The measure of angle A is equal to itself. So if the measure of angle A is 30 degrees, well, 30 degrees is equal to 30 degrees. An angle is equal to itself. A segment is equal to itself. A number is equal to itself. The symmetric property means that if we flip our equation around, then it still has the same value. So if I know that, like in our last example, x is equal to -1, that's the same as saying -1 is equal to x. I'm allowed to simply turn the equation around. The same holds true with segment lengths. So if I know segment AB is the same as CD, that's the same as saying CD is the same as AB. It doesn't matter which is written first in the equation. Same holds true with angles. If the measure of angle A is equal to the measure of angle B, I'm allowed to reverse that and say the measure of angle B is equal to the measure of angle A. And then the last important property is the transitive property. All right, so we'll use the example. If A is equal to B and B is equal to C, so they're both equal to B, then we're allowed to conclude that A is also equal to C. So an example of what this might look with values is if I have 3 plus 4 is equal to 7, and 7 is equal to 7 times 1. Since they are both equal to 7, I can conclude that 3 plus 4 is equal to 7 times 1, because they're both equal to 7. Same conclusion can be drawn for segment lengths. If AB is equal to CD and segment CD is equal to EF, well, they're both equal to CD. So if they're the same as CD, then that means they're the same as each other. Same holds true with angles. If the measure of angle A is equal to measure of angle B, and measure of angle B is equal to the measure of angle C, well, they're both equal to the measure of angle B, therefore they are equal to each other.